Namaskar. Welcome to the session on taste quality, modification, thresholds and measurements. Coming to the introduction. The basic tastes sweet, sour, salt and bitter are independent entities. They do not have the ability to change into another. As known, these are reflected as the effect of molecular structure. The quality of these tastes is an intensity based perception based feature. These exhibit different thresholds depending on the molecule and perception. Many a time, the modification of the taste is attempted, practiced to suit the palate. Therefore, these properties are of great concern for better perception, food development and acceptance. We will be learning the taste under following sections: taste quality, taste modification, taste thresholds. First, coming to measurement of taste, and under that is the taste quality. The taste quality has no clear-cut dimension and is more a human perception. It is influenced by geographical, environmental, physical, physiological, psychological, technological and nutritional factors. Early studies of 19th century expresses the opinion that 4 basic taste qualities fall into a single taste modality just as colors are with qualities within vision. Kiesau, Birch et al. 1977 is the first one to conduct a systematic study on taste mixture interactions. He revealed that mixtures tasted less intense than the components. Also, the concentration of each component have an influence on the taste perceptions. Very low concentration component may not be recognizable for its quality impact, but still adds to the overall quality of food. Even though no chemical reactions occur, the mixture of taste qualities changes the intensity of perception. On the other hand, Orwell, Birch et al. 1977 compared the taste quality to the skin, which senses touch, warmth, cold and pain than the color comparison. Thus, they are independent entities which are not able to change to another. Amongst the taste qualities, bitterness resembles sweetness because of stereochemistry of stimulus molecules. For example, when sugar molecules are chemically modified, the resulting derivatives are almost bitter or maybe sweet bitter. Thus, it is truly a molecular effect depending on stereochemical, hydrophobic and polar structure features showing varied responses. This gives an indication that molecular patterns ultimately are responsible for both basic tastes. In the case of saltiness and sourness, though the taste quality is on molecular pattern of cation and anions, the intermolecular changes do not arise. Sour, bitter and sweet taste decreases with increasing addition of monosodium glutamate. Salty taste increases with increasing monosodium glutamate only at the flavor threshold of sodium chloride. The pleasantness of sucrose increases with the increase in concentration, but at a higher concentration it decreases slightly. In case of sodium chloride, tartaric acid, quinine sulfate, the pleasantness will be experienced with slight increased concentration, but later it will be unpleasant. There are so many factors that alters taste perceptions. The factors are age, meals, hunger, taste medium, temperature, smoking, obesity, pregnancy, cold, cough, allergies and diseases. Taste discrimination decreases with increase in age. Around 45 years of age, taste buds begin to degenerate. Taste loss becomes apparent in late 50s. In advanced age, taste thresholds for sweet, salt and bitter are 2.5 times higher than in the young. Sensitivity is reduced after the meals. It also depends on the type of the meal, whether spicy or bland meal. Hungry persons are more sensitive to sweetness and saltiness. This makes to overcome the hunger, which is not good. Taste medium of liquid helps the taste buds to detect flavors. Water is the best medium for sensitivity test. Taste thresholds are lower in water than in fruit juice. Increasing temperature increases the response to sweetness but decreases with saltiness and bitterness. Decreasing temperature increases the response to bitterness but decreases for sourness. Smoking reduces the taste bud sensitivity to all the basic tastes. Children and adolescents who are obese have less sensitive taste buds. Therefore, intensity of sweetness of sweets will be less, bitterness will be mild, and salt may not be really perceived. Pregnancy shows that reduced sensitivity for salty taste. During cold, cough, obstruction of nasal and oral passages reduces the sense of smell first and taste bud sensitivity later. Any disease reduces the sensitivity but improves after treatment. Now next, coming to taste modification. Taste modification is a very interesting phenomenon to the consumers. The taste modification physically modifies the perception of a compound, food, drink, etc. The taste modification can be achieved by combination of the basic tastes and taste sensations, by topical application, by the use of condiments, by the use of flavoring agents, by the use of texture modifiers and synergism. However, the modification can also be met by a negative path of approach through suppression, masking and disorder. The basic taste and taste sensations at times may have a combined phenomenal action for the clarity and expression of perception of food. For example, bitter taste and pungency of ginger, acid taste and astringency of betel leaves may provide a better impact for the sensory organs for expression of perception. In many of the fried snacks, vegetable salads, cut fruits, salt and pepper, cardamom powder, sugar powder are used for topical application prior to consumption. The taste quality modifies, but the independent taste remains during perception. Similarly, the use of condiments, flavoring agents result in mixed interactions among the four taste qualities. When substances are mixed, their taste change, but no chemical reaction occur among the substances. The use of starch or dal powders in food systems changes the texture as well as the taste. The taste quality is felt in terms of reduced intensity. The saltiness perception is reduced in starch thickened foods with the reduction in mouth amylase activity. Ferry et al. 2006. In a model system of 4 sugars, sucrose, fructose, glucose, maltose, when subject's concentration versus the perceived intensity is seen, it reflected psychophysical function with a greater strength of perception, which shows the expansion. The mixture of these sugars tasted much stronger than the simple sum of single components taste scores showing the synergism. The taste flavor interactions in the study of sucrose caffeine system have shown their reciprocal action on suppression, that is the perceived intensity of say sugar increase, the caffeine intensity decreases. Similarly, sucrose with tartaric acid system, suppressive action of sucrose on the sourness of tartaric acid is greater than the suppressive action of tartaric acid on sweetness. Marin et al. 2002. Besides these, taste can be suppressed by local anesthetic application on the tongue. Amiloride, a blocker of epithelial sodium channels, reduces the salt taste in humans. Adenosine monophosphate may block the bitterness of several bitter compounds. Gymnemic acid from Indian shrub Gymnema sylvestre decreases the sweet perception. Chlorogenic acid and cyanorin, by suppression of sour and bitter taste receptors, enhances the sweet taste. Miraculin, a miracle fruit, turns sour taste sweet by binding the site near the sweet receptor. Masking is another aspect of taste to eliminate undesirable taste. Acid taste is masked by using more quantity of sugar or sweet compounds. At times, the condition of disorder of taste is experienced and is associated with smell. It may be decreased perception of taste, hypogenusia, due to the reduction in taste buds, or loss of sense of taste, ageusia, or distorted ability to taste, which is dysgeusia. Thus, the taste modifications reflects on the relative intensity of basic taste through one of the processes of suppression or expansion, masking and disorder, depending on the components used and the system of application. Besides these, the reaction time is also an important factor to express the changed perception. The reaction time is the interval between initial stimulation of the receptors and the report of the reaction. The reaction time to taste has been reported as 0.02 to 0.06 seconds as per the electrophysiological studies. However, the oral response reaction time for salt, which is 0.307 seconds, for sweet 0.446 seconds, for sour 0.536 seconds, and for bitter 1.082 seconds. The oral response reaction time depends on the concentration too and the technique adopted. Relatively, taste has slow reaction time as compared to other sensory stimuli. Receptor transduction mechanism with the comparison of retention time to various typical substances with the same taste quality with the same subjects when studied, no significant effect was seen on the stimulus chemical composition. Though retention time is short for salt and longest for bitter, retention time among the four basic tastes is small. The taste retention time varies widely with its taste intensity. The reaction time in analyzing the flavor of chewed gummy candies suggested that retention time of that of taste components was not responsible much for detection time as compared to intensity of odors. Taste thresholds. Taste threshold is a statistically determined point on the stimulus scale at which occurs a transition in a series of sensations or judgments. There are four types of thresholds that are generally known. First is the absolute threshold, second is the difference threshold, third, recognition threshold, and fourth, terminal threshold. Absolute threshold is that magnitude of stimulus at which transition occurs from no sensation to sensation. It is also referred at times as detection threshold or stimulus threshold or sensation threshold. Difference threshold is the least amount of change of a given stimulus necessary to produce the change in sensation. Recognition threshold is the minimum concentration at which a substance is correctly identified. It is also referred as identification threshold. Terminal threshold is that magnitude of a stimulus above which there is no increase in perceived intensity of the appropriate quality for the stimulus. Above this point, changed sensation of pain, burning, piercing often occurs. The threshold measurement is the procedure of studying the psychophysics of taste which concerns the functional relation between stimulus and response. Taste thresholds is a complex phenomenon since the data depends on the subject, difference in techniques employed, and statistical compliance, the effect of temperature, environmental factors, and time of the day, experience, age, sex, and physical condition. Even given the same subject and method, because of varied factors, the variations in the taste threshold is expected. In general, the absolute threshold is much lower than the recognition threshold. Each compound will have a unique threshold level which depends both on the properties of the receptor and the concentration of the molecules. It has been found that the integrated response of concentration of sodium chloride by the receptors on the tongue with the cauda tympani cranial nerve reveals that at 0.32 molar concentration, response is maximum and later remains constant even up to 1.1 molar. That means to say that after certain level, the saturation is reached with no changed response. Generally, recognition threshold, which identifies the minimum concentration, is followed and is expressed as percentage. But it has been found that recognition threshold and absolute threshold is much closer together for bitter tasting than for sweet or sour tasting compounds. The threshold values of selected compounds are given in table 1 to table 4. The threshold value is affected by various factors such as lack of sleep, hunger, age, habits such as smoking, alcoholism, cold, fever and allergy. Besides these, the temperature influences the taster. The optimum temperatures have been reported for sucrose and hydrochloric acid as 35 to 50 degrees Celsius, salt 18 to 35 degrees Celsius and 10 degrees Celsius for quinine. The medium such as the liquid or solid also influence the receptors, thereby the threshold value. The interaction of taste, say 2 or 3 basic sweets together, has an impact on threshold value by way of increase or reporting the sensation of highest first and later others. Measurement of taste. The measurement of taste depends on which taste to be determined. Secondly, depends on the food products and quality control methods followed are compared with the sensory evaluation of taste. Thus, both objective and subjective measurements have to be followed for evaluation of the taste of the product. Some of the points of concern for subjective and objective measurements are: the samples for both tests should be identical, there must be sufficient replication, the same individuals should participate in all panels for comparison, sufficient range of test variable to be chosen, degree of variation from sensory panel to instruments results to be determined. The objective instrumental methods vary depending on the basic taste to be determined or the product from which the taste component to be identified and quantified. Still, the limitations exist in terms of specific factor determination by instruments, whereas human responds to various sensory attributes. Specificity for mouth feel will be more relevant for taste measurements. The evaluation of taste of any food product should be based on the fields of psychology, which describes the responses to sensory stimuli, psychophysics, which quantifies the relationship between stimuli and response, and statistics, which formulates the precision judgments. The methods followed for taste evaluation are ranking, scoring, hedonic scaling, and evaluation. Ranking is the test followed for selection of one or two best samples rather than testing all the samples thoroughly. This is often used for screening inferior from superior samples in product development and sometimes for training the judges. Scoring is the most commonly adopted method to grade the quality to the property is taste in this case. This needs a methodical approach to development of scorecard, specificity of properties to be graded, concept known judges selection. Scoring has the advantage of statistical analysis and confidence level of the test. This test can be structured scale or non-structured scale. Hedonic scaling relates to the psychology of pleasurable or unpleasant property. In this method, the human discrete values of like, dislike with an adjective of extremely, fairly, poorly are used with the scoring for evaluation. Therefore, this is a direct method of defining the responses with the proper judgment. This is also advantageous for statistical analysis and inference. Dilution method is a specific technique adopted to detect the smallest amount of unknown sample when mixed with the standard material. This is more used for determining the threshold levels of basic tastes. The recent development for the taste evaluation is the use of electronic tongue. Professor Frederick from Sweden University has invented the electronic tongue, which measures and compares taste. In the biological system, taste signals are transducted by nerves in the brain into electric signals. E-tongue sensors process also generates electrical signals as potentiometric variations. Taste quality perception and recognition of activated sensory nerve patterns by the brain and on the taste fingerprint of the product. E-tongue statistical software achieves the same and further interprets the sensor data into taste patterns. Reference electrode and sensors are a part of the system. The measurable current response as a result of oxidizing reactions shows the voltage difference and after amplification recorded by the e-tongue's software. Electronic tongue have the applications in food and beverage and pharmaceutical industry. Conclusion: taste quality is rather more a human perception influenced by geographical, environmental, physical, physiological, psychological, technological and nutritional factors. Taste quality is intensity-based perception and depends on the threshold concentration of particular component. Generally, the factors that affect the taste quality are age, hunger, duration between meals, taste medium, either liquid or solid or viscous, smoking, drinking, body status in terms of obesity, pregnancy, cold, cough, diseases. Taste can be modified by combination of basic taste by use of spices, flavors and texture modifiers. The undesirable flavor can be overcome by suppression and masking. The increased temperature aids in increased intensity. The reaction time of perception ranges from fraction of a second to a few seconds for the basic taste. Each compound has a unique threshold value. Both subjective and objective methods are followed for evaluation. Objective methods assess the taste and quantifies the component. Ranking, scoring, hedonic scaling and dilution methods are followed for subjective evaluation. Recent development is the use of electronic tongue with the statistical software.